Welcome to Coding Practice Academy. Today we learn advanced printf function features and use of scanf function to read value from keyboard. Let's explore the program. Let's explore this program. This is a program of advanced printf function and we are using the scanf function. This is the first occurrence of the scanf function. The program started with the hash include str.h void main and open bracket, and that bracket should be closed. And all these sections is already discussed. I'm providing the link above. If you want, you can watch that link. Now, what is our target? We want to put two values. One is of integer type, another is of floating type for our program requirement. So we need to take two variables. One is of integer type. The name of the variable is first int underscore val, another name is float underscore val. The first int underscore val is of integer type, second float underscore val is of floating type. Now we also know integer is int is a data type, so we can't declare int as a variable, so that's why int underscore val is used. The similar concept is applicable for the float underscore val also. The next line says printf enter the value in integer and float format. What is the purpose of this statement? Just it is helping the user to input data first in integer, then is floating type format. Once the data is entered by the integer, how the data is being entered by the integer, and it is used by the scanf function. So scanf function, what is the purpose and what is the utility, what is the syntax, all are being already discussed in the previous videos. Link is again given above. If you want, you can watch. Here in the scanf function we are using two field specifier. What is this two field specifier? One is %t, another is %f. The % is for integer type value variable. So what is that integer variable? Int underscore val, and we are using an ampersand before the variable. That means the value entered by the user is stored in the memory location of this variable. Similarly, the floating type value entered by the user is stored into the memory location of this floating type variable. Now the value entered by the user is complete. Now we want to display what is being entered by the user. So original input value is %d, then \n, comma int value. Now what is the purpose of this \n? The \n takes the cursor to the next line beginning position, so that the next output will start on the beginning of the line. After the first printf statement, there is a second printf. What is the purpose of the second printf? Now here we want to print the signed decimal integer of the entered value. For this purpose we are using the %i. Next we are printing the octal integer. For that purpose we are converting the input data to the octal integer. So for this purpose we are using the %o, and this output will be printed without leading 0. The next is input data is converted to the unsigned decimal integer and the field specifier is used %u. The last, in the printf statement of this conversion, we are converting the input value to hexadecimal integer and the field value is %x. So after that we are using the field width specifications within the printf statement. What is that? Let's find it. What is it? We know how to use the %d. Here instead of using the %d, we are using a %6d. What is that 6d? The 6 is the field width and the value is right justified. So for example, suppose you are mentioning the 6d. So in the screen there are 6 locations are created, 1, 2, 3, 4, 5 and 6 with that field width. into format specifier. And suppose user enters the 545. So the value entered by the user is write justified with the 6 consecutive locations. Next is we are using the %2d. What is this? In the field specifier, the field width is 2 now, where the input value is 545. So when the input value is larger than the field width, the entire value is printed, ignoring the field width. The next is we are again using 6d, but before that 6 we are using the minus sign. So what is the minus sign? The value will become left justified. So the value will now printed in this location 545, though the 6 locations are already reserved for this 60. Next is we are using again 6d, but there is a 0. What is that? Now for 6d, 6 locations are reserved. So and the value is again 545, but here 0 is mentioned, that is %06d. So value is right justified, but these blank locations are filled by the zeros, leading zeros. So it will say 6 is the field with right justified with leading zeros. Next, the field width with the decimal precision. Now we are using the %8.4f. Suppose the user enters 23.4563. Now the field width specification is %8.4. So for this 8 locations are reserved. 1, 2, 3, 4, 5, 6, 7 and 8. And after decimal, that is 0.4. That is decimal 0.4, that means 4 locations are there. 1, 2, 3, 4. And the total value is right justified. So this 23.4 will look like that when it will be printed in the output. Next is we are using %8.1f. So what is the purpose? Rounding after decimal. So if you are printing that is 4563, the output will be shown as 23.5, and after decimal there is only 1 point, that is 5.5. The entire value is right justified. In this case it was right justified. Now if we are using the minus sign before 8.1, the entire value will become left justified. That's with the minus 8.1, it will become 23.5. 23.5. We'll check all those values with our output. Here you are using only %f, no field width is mentioned, so the total value will become 23.4563 and 2 other values, because for the %f after decimal there are 6 digits are there. And the last is the E stands for the exponential notation for this 8.1e. So let's compile this program. Compilation. There is no error in the program, so we can go for the execution. Execute it. Execute it. So what is our input value? 545. 23.4563. Press enter. Now original input value, I am taking back you to this screen. See that original input value, it will print the original input value 545. As I told, the sign decimal also same as the original input value 545. Now this is the octal integer value of the given input, unsigned decimal integer of given input, hexadecimal integer of given input. Now the field width part. What it says, the first is %60. So first 1, 2, 3, 4, 5, 6 locations, and the output is right justified. The field width is %2d, so field width is less, so the original value is printed with the left justified. We are using -6d, though there are 6 locations are there, but the total value is now left justified. See that we are using the 0, 6d, so that it will covered with the leading zeros. 3 leading zeros are there, and the output value is again right justified. After that, we are using the field width specification with the for the floating point, that is 8.4. So first, in this case, there should be 8 locations. 1, 2, 3, 4, 5, 6, 7, 8. 8 locations are there, including the decimal point, and the total value is right justified. Next is 8.1. So the last value, that is 45, is rounded off and it is now 5. So after decimal there is only 1 digit, and the total value is right justified. Next line is we are using the -8.1, so that same value 23.5 is now left justified. And next point we are using %f, so 23.4563 is there, and 2 other values, because for floating point there should be 6 decimal digits after the value, integer value. And the last is the exponential notation of this given value, that is 23.4563. So this is the entire discussion regarding the advanced printf function and using the scanf function to take input by the user. Thank you.